Welcome to this explainer, made by Forge College. Today, we're going to sketch out the exact engineering blueprint you need to measure your Solana application's heartbeat. We're talking about KPIs, or Key Performance Indicators. So, grab your mental technical pens, because we're going to draw up a super clear, structured system so you know exactly what's happening under the hood of your deployment.
Picture this. You've just finished your final deployment run. The code is live, you're sitting back, sipping your coffee, and looking at a perfectly quiet dashboard. But let me ask you a kind of terrifying question. Is your app actually working perfectly, or are you just experiencing the blissful, silent panic of a total crash just because nobody set up the right metrics to watch? Seriously, a quiet system isn't always a healthy system. Sometimes it's just a system that has completely lost its voice. All right, let's look at the agenda. We've got 6 parts today. 1. Moving beyond the deployment checklist. 2. The KPI monitoring pyramid. 3. 5 steps to prioritize KPIs. 4. The KPI scoring formula. 5. Prototyping a Solana wallet. And finally, 6. Preparing for monitoring tools. Let's get to work.
Section 1. Beyond the deployment checklist. Okay, so let's dive right in. In our previous lesson, we spent a lot of time defining roles and responsibilities and really finalizing those deployment checklists. We figured out exactly who owns what runbook and what needs to be turned on. But right now, we have to bridge the gap between just turning the lights on and actually measuring how bright they're shining. Notice the distinct line between action and observation here. On the left, your deployment checklist is really all about the what, like what must be deployed. Are the validators running? Are the RPC endpoints configured? But on the right, KPIs are all about the how. How are things running in production? Are those RPC endpoints actually returning data fast enough, or are they just crawling? See, a checklist ticks a box to say a component exists, but a KPI constantly measures whether that component is actually meeting your real-time expectations. Moving on to Section 2, the KPI monitoring pyramid. To really capture that real-time performance, we need a solid architectural framework. Let's look at how that's built.
We really need a mental model that stops us from making that classic rookie mistake of only watching low-level system metrics like CPU usage while completely ignoring the actual user experience. We call this the KPI monitoring pyramid. We stack these 4 layers to build a complete picture. Right down at the foundational base, we have infrastructure health. This asks the absolute simplest question: is the platform even running? Moving up to layer 2, we check platform performance. Is the network meeting expectations like block times and throughput? Layer 3 is application correctness, meaning are transactions actually producing the right results? And finally, sitting all the way at the very peak is user experience. End-to-end latency. Is the human on the other side of the screen actually getting value out of your app?
Now, I want to pause for a second and define this specific layer, the correctness KPI, because it is absolutely vital. This metric ensures transactions are doing exactly what they're supposed to do without state divergence. Basically, it prevents that dreaded silent failure, where your infrastructure says, hey, I'm fine, CPU is at 20%, but literally all of your users are getting signature verification errors. Monitoring correctness is how you successfully triage incidents when the system falsely seems perfectly healthy.
Section 3. 5 steps to prioritize KPIs. Here's the reality check, though.
If you try to monitor every single metric across all 4 of those pyramid layers, you are going to drown in data. You will literally go crazy with alert fatigue. To avoid that, we enforce a strict 5-stage drafting process. First, you list out your services and core user journeys. Second, you map out every single way those journeys can fail. Third, you select candidate KPIs to measure those specific failures. Fourth, you score and rank them. And fifth, you define the actual alerting rules based on those scores. You just can't write a meaningful alert until you know exactly which user journey it protects.
Let's look really closely at step 3 for a second, selecting candidates. Choosing vague metrics is about as useful as handing a builder a blurry, water-stained blueprint. Like a bad KPI simply says latency. Latency of what? Average? Median? It doesn't tell us much. A good, precise KPI says RPC 95th percentile latency. It gives you an exact, measurable threshold, so you know exactly how the vast majority of your users are experiencing network congestion. Section 4. The KPI scoring formula. Once we have those precise candidates, we move straight into step 4.
We've got to score them. We need to apply a little bit of math to figure out which of these metrics actually deserves to page your on-call engineer and wake them up at 3 a.m. Our scoring formula breaks down into 3 distinct weights.
Impact carries the heaviest load at 50%. How many users or critical functions are broken. Frequency is next at 30%. How often does this specific issue pop up? And detectability is 20%. How quickly and easily does our system actually surface the problem? By weighing impact so heavily, we guarantee that widespread, catastrophic failures always bubble up to the absolute top of our priority list.
Now, a major factor in that detectability is your detection window. This is simply how soon you need to know about a failure before a minor glitch turns into a total disaster. For example, an RPC outage has a detection window of seconds, while a slow fee estimation algorithm might take hours before causing any real damage. And hey, just a quick aside, mastering these kinds of nuanced operational techniques is actually a big part of the learning community in Forge College's advanced programs.
All right, Section 5, prototyping a Solana wallet. It's one thing to look at abstract formulas, but it's way better to apply them to a live architecture.
So let's prototype the monitoring strategy for a typical Solana wallet service. Following our workflow, step 1 is anchoring our metrics to actual human experiences, our core user flows. For our wallet, the absolutely critical journeys are users sending token transfers, users swapping tokens via an on-chain DEX, and the system processing background state claims. Every single thing we measure must protect these three experiences.
When we're mapping failure modes for these flows, a really huge risk factor is indexer lag. This is the difference in block slots between what the blockchain actually says and what your wallet's internal database thinks is true. High indexer lag is a total nightmare because users look at their screen, see stale ghost balances, assume their transfer failed, and then angrily initiate duplicate transactions. No one wants that. So, let's look at the resulting blueprint ledger for our wallet. We score our candidates. As you can see, RPC availability gets a massive impact score of 10 and high detectability, landing it firmly in high priority. Transaction confirmation latency and swap failures also hit high priority. Interestingly though, while indexer lag causes those super annoying ghost balances, it might not completely halt the whole network for everyone instantly, so its impact scores a 7, placing it in the medium priority tier. It's definitely a critical trend to watch, but maybe not a 3am pager event compared to a total RPC blackout.
Finally, Section 6, preparing for monitoring tools. We've built our pyramid, we've scored our metrics, and we have our prioritized list. Let's see what's next.
The big question is, what do we actually do with these engineering artifacts to prepare for our next phase? Well, we have to turn this abstract list into concrete operational rules. First, tie them directly to the runbooks we finalized in the previous lesson by assigning primary and secondary owners. Next, set aggressive alert thresholds for your high-priority items. For your medium-priority items, like our indexer lag, you want to build trend dashboards that flag sustained issues over time. And for low-priority data, just quietly collect it in the background for future capacity planning so it doesn't clutter up your immediate view.
So the absolutely crucial point here is this. You must clearly define those aggressive thresholds. If an ultra-critical metric like RPC availability drops below 99% for even just a single minute, that is an immediate, loud alert. That pager needs to ring instantly, routing straight to the assigned owner with the correct runbook right in hand.
And that brings us to the final check. Are your artifacts ready for observability tools? You now know how to map a user's journey to a specific prioritized KPI. So your homework before our next lesson is to finalize your own KPI notes. Pick at least one high priority and one medium priority KPI for your major services and define those thresholds. Because next time, we're taking these artifacts and plugging them directly into actual monitoring and observability tools. To explore more about this curriculum, dive deeper into Web3 infrastructure, and continue your learning, make sure to visit forge.college. Keep building, and I'll see you in the next explainer.